All right, we are going to solve square root equations in this video. And so I have two different square root equations here on the board. We're going to start with this one. It's the simplest one. When you solve a square root equation, you're going to square both sides to get rid of that square root. But before you start, you need to get the square root by itself. It's just easier that way. So I'm going to move the 3 to the other side. And then I have the square root of x plus 3 equals x minus 3. Now, I'm going to square both sides. Now, when you square both sides, you have to square the entire side. You cannot square the individual members of a side. All right, so this is easy. The square root sign just goes away. But over here, x minus 3 squared is really x minus 3 times x minus 3. So we're going to need to use FOIL to multiply this out. So we've got x plus 3 equals, and then x squared minus 6x plus 9. Now this is a quadratic equation. When you solve a square root equation and the square root signs go away, you're going to either have a linear equation or a quadratic equation. All right, so we're going to move everything to one side, have 0 on the other, so I'm going to subtract my x. And then I'll have 3 equals x squared minus 7x plus 9. And then I'll subtract my 3. Remember, we do this so that we can factor this to solve it. Now, if it doesn't factor, you can use the quadratic formula on it. But this one will factor. And so when I factor this, and I'm just going to put this over here, then I have x minus 6 times x minus 1 equals 0. Now, this means that x minus 6 equals 0 gives me that x equals 6, and x minus 1 equals 0 tells me that x equals 1. When you solve a square root equation, you're going to have to put these answers back into the original statement to make sure that it works. There are domain problems with square root functions, and so not every number that you get for an answer will make the equation true. So when we put 6 back in, then we get the square root of 9 plus 3 equals 6. Well, the square root of 9 is 3. 3 plus 3 equals 6. That works. All right, when we put 1 in, then we get the square root of 1 plus 3 equals 1. Well, 2 plus 3 does not equal 1. And so 1 does not work. So 6 is really the only answer here. All right, now let's look at a more complicated square root equation. Now, this square root equation, I'm going to need this room, so I'm going to erase that. This square root equation has 2 square roots. If you want to, you can square both sides the way it is, but it's usually easier if you separate the square root. So I'm going to move this square root to the other side. Now, you don't have to do this. You will get the same answer if you leave it over here and square both sides. But I think this is generally easier. All right, now I'm going to square both sides, and when I square this side, of course, that square root sign goes away, so I get x minus 2. But when I square this side, here again, I have to use FOIL, because I have 3 minus the square root of 7 minus x times 3 minus the square root of 7 minus x. So we're going to have to use FOIL to do this. So I have x minus 2 equals 9 minus 6 times the square root of 7 minus x. And then the square root of 7 minus x times the square root of 7 minus x is plus 7 minus x. All right, well, I have a like term over here. X minus 2 equals 9 and 7 are 16 minus 6 square root of 7 minus x minus x. Now, I want to get everything but this square root term on the other side. So I'm going to add x to both sides. And I will have 2x minus 2 equals 16 minus 6 square root of 7 minus x. And then I'll subtract 16 from both sides. All right, so now I have 2x minus 18 equals negative 6 times the square root of 7 minus x. Now, I can divide everything by 2. And actually, I'm going to divide everything by negative 2. It just makes my number smaller. If I divide everything by negative 2, then I'll get negative x plus 9 equals 3 times the square root of 7 minus x. I just do that to make things easier, and in fact, we can even turn this around if you want to and make it 9 minus x equals 3 times the square root of 7 minus x. And now I'm going to square both sides. You don't have to do some of those steps, but it just simplifies the process. All right? Now, when I square both sides here, I have a binomial over here. I'm not going to write it out. I'm just going to write it like this. 81 minus 18x plus x squared equals, and then here I have to square both of these. 3 squared is 9, and then the square root of 7 minus x squared is just 7 minus x. All right, now, I'm kind of out of room, so I'm going to erase my work on the previous problem. We don't need that anymore. And we'll come over here and rewrite this so that the x squared is in front. X squared minus 18x plus 81 equals, and then I've got 9 times 7, which is 63, minus 9x. So what I did is I just used my commutative property of addition, which says that the order doesn't matter. I can change the order when I'm adding, as long as I keep the signs with the terms that I'm adding. And then I used my distributive property over here to get rid of the parentheses. So I've got a quadratic. I need to put everything on one side. So I'm going to add the 9x to both sides. And when I do that, I have x squared minus 9x plus 81 equals 63. And then I'm going to subtract the 63 from both sides. And then I have x squared minus 9x. And then 81 minus 63 is 18, positive 18, equals 0. All right, and so I'm going to factor this. And when I factor it, I get x minus 6 times x minus 3 equals 0. So x minus 6 equals 0, gives me x equals 6. X minus 3 equals 0, gives me x equals 3. All right, I need to put those back in and see if they work in the original statement. Well, if I put 6 back in, then I'll have the square root, so x equals 6. Then I'll have the square root of 4 plus the square root of 1 equals 3. Well, 2 plus 1 does equal 3, so that works. Now, when I put the 3 in there, then I have the square root of 3 minus 2 is 1. Plus, and then 7 minus 3 is 4, the square root of 4, and we've already seen that that does in fact work. So both answers do in fact work on this problem.